Okay. Okay, so we have three methods. We're going to talk about this method. These pictures are taking your area and rotating them and creating your solid. So this one, say this would be my area. So we're going to find the area the same way. You're going to feel, you're going to enclose it. It's going to say here are your boundaries, just like you did, for this thing. But then what you're going to do is you're going to create, oh, actually this one goes this way, doesn't it? It goes all the way here. Okay, and what do we do to create this solid figure? We rotated it about the x-axis. And it creates this kind of look, this piece right here that's shaded in, we don't need that. It just is like the 3D look of it. It's not really shaded. But that's your original area, and then we rotate it this way, okay? This one, same thing. You have your x-axis, don't ask me why, it's just another perspective thing. We probably have this area, and again, we rotate it around the x-axis, and it creates that solid, okay? This one right here is probably more like you've seen maybe a paperweight where it's already solid, and you're going to slice it with cross sections, okay? So this is not created by rotation, and that's that. Okay, here's another rotation. We take this, probably up here, and we rotate it around the X again. The first, we're just creating, we haven't really talked about whether it's a disc or a washer yet, sorry. We're just creating how the solid is creating by doing the rotation. This goes with this, I think. You rotate it. And yeah, here it is. That is right there. Okay, you rotate it, but you got a little hole in here because you've got an open space here. So, but if you rotate it again across here, you're going to create that bowl-ish looking thing. If you can imagine it, it helps, but it doesn't. Like, if you can, it's really okay. You can still work it out. Okay, but that's when Calc 2 gets weird because you got all these 3Ds, and if you can't draw them, it's really hard to like envision it. So that's when you need a friend like Allie around to draw for you. Sorry. This one right here, yes. This one we took this area and we rotated around the Y, so it created this cone-ish like thing. Okay. And they will tell you, it is hot, they will tell you where you're going to rotate it to create the volume, but that's what we're doing in this section. This is another cross section where, again, it's like this solid is already here, and then we're going to slice it up. It looks like we're slicing it in terms of triangles. All the triangles would be different sizes, but it's like they'd be laying straight, like same thing here. These are like maybe little trapezoids, but they'd be flat, okay? Anyway, so that's the general idea. So we're going to do some solids, and we are going to start out the same way we start out this way, and then we're going to rotate them, and we're going to create that solid. So this is your area, and then you rotate it about something, and you create the solid. So that's the grand plan. All right, so we have a graph, and when you rotate it, you have a solid. So which one matches with which? This one matches with? That's right. And what did you rotate it over? The x-axis. Very good. Okay. What does this one match with? First. Yep. And you rotated about the X again. Okay. And how about this one? And you rotated about the Y. Very good. Okay. So again, they will tell you that. You don't have to like figure that out, but
So we not have to do this whole
No. Okay. So this is the, I know, aren't they good? This is the solid that you can actually see the discs. The discs here are very fat. What you have to remember is that when you slice it up, you are finding little skinny discs, like almost like, what are the CDs, except they won't have a hole in it. But that's like a ream of paper. Those are your discs, except they're not round. But anyway.
I don't work on one though.
Yeah. Well, you can just leave it in Smart, and then you can watch it all day long. But anyway, these right here are the disk areas that we're going to be finding. Okay, so let's get a move on here. Okay. A solid revolution is formed by revolving an enclosed area around an axis of revolution. So we already talked about that. The axis is either going to be horizontal or vertical, and that is key to the whole problem. So you got to determine that pretty much up front. And there's a kind of a key, so you won't have to worry about it. You just have to think about it. Okay, so how do you find the volume of that disk that I just turned around? How do you find the volume of this? What do you need to find the volume of this little disk here? Radius. Right. This would be your width. In this case, it would be your width this way. Okay. Height over here. So what? It's a cylinder, right? The volume is pi r squared h. Like area of a circle times its height. Okay. So we did that, but remember they're skinny, they're all lined up in there beside each other. All right. Okay, so I've got f of x equals the radical of sine of x, looks like this. Okay. I have, that's our boundary. So that's there. All right. And we are rotating it. Oh, another boundary is x-axis. So that's that. So your area, again, if you were just doing area, would be right this piece right here, right? Okay. You're going to rotate it about the x-axis. Have it, and it's going to look like this. And it's all said and done. It looks like it might be a little pointier. I got a link. So let's see if it works today. Sometimes it does, sometimes it doesn't. Where is it? There we go. It kind of shows the development of the solid. Okay, we'll check in later. All right, so what you have is your radius right here. Okay, that's the radius from a disk that's looking like this way. You're chopping up all those disks. Okay, so we're going to start with, we're going to say, we're going to do disk. Here's the K. All right. Area of a circle first, because a disk is a circle. How do you find the area of a circle? Pi r squared. Then the volume of the disk would be pi r squared h. Okay. The h, remember, is the width, and that is in terms of x or y. Which one is it? That's right. Very good, Sarah. Say it again. Right. So it's whatever it's perpendicular to the axis of revolution has to be perpendicular to the radius. All right. So here we go. All these then is change in x. We hit the x-axis. We're going to do change in x. Okay. Now, to do the area, remember that was an integral. So we're just going to do pi times that area. I'm going to leave my pi out here because it's just going to mess up all my numbers. Okay, we're going to go, what's my radius? Right here, top to bottom. Radical sine of x minus the bottom, which is 0. So it's really radical sine of x. Don't forget we are squaring because we are in a circle. And changing x turns into dx. Okay? It's the very skinny width of the cylinder that they're not really looking at you. They're all sliced up. Okay. Limits. Of course, the one starts with 0. What's the end of this one? That's where sine of x, radical sine of x equals 0, which is where sine of x equals 0, where x equals,
That's fine. Or x is 0? No.
that's 0. What is it? 5.
I said if I didn't.
Well, no, I also heard pi over 2 and such. Okay. So pi, 0 to pi, what's the radical sine of x squared? Sine of x dx. Okay? It's a simple enough one. Let's do it by hand. Again, I'm going to leave this set for a minute. All right, what's that? And what's the antiderivative? Negative cosine from 0 to pi. No idea where that was.
The negative.
Why did I put negative pi?
Oh, you're gonna.
Because I moved the negative cosine out here.
All
All right, so negative pi. And cosine pi minus cosine 0. What's cosine pi? And cosine 0. So what's that? 2 pi. Okay. Should we get negative volumes?
No.
Got itchy eye here. I'm not sure what it's doing. Hannah noticed. All right. Any questions? First thing we want to figure out is this width, because if it's in terms of y, then we need to switch up the equation, yada, yada, yada. But you got it? Yes, Lindsay. But that's r squared. Pi r squared. That's r. That's r. That's r. From the axis of rotation to the outside, that's your r. R only goes, remember, on your disk. That's your r from the center out. Sure?
So then, what is so the curve and the R is I think I'm just confused.
The r is the distance. Everywhere, these are all r's right here.
Oh, okay.
And they all are from radical sine of x minus 0. The x is going to change, so it's going to change that length, but they're all, like if you plug in pi over 2, the sine of x, pi over 2 is 1, 1 minus 0, that one would be 1. Okay. That's the only one. That's the volume of the shape. Yes, that's the volume of that shape. And they're all in terms of pi, so they're like, I feel like there's not much, like they don't really make sense because pi is just like a.
So the R is the radical sine x.
Yes.
Like the
This is r. No, this is r. We do r the same way you found your length of your rectangle when we were doing area. When you did area back here. One more. This length right here, that's gonna be the same as your arm. How long is that disc from this axis of rotation to the end? Let's try another one. Okay, find the volume of the region in the first quadrant, so that's a boundary. Bounded by the axes, there's another boundary, and the parabola 1 minus x squared. All right, what does 1 minus x squared look like? It's a parabola facing down at 1. Okay, so there's 1. All right, first quadrant. So probably this and that. Okay, so what you're rotating is just this piece, because you got an x and a y boundary, it says, and you're revolving it about your y. Okay, so you're going this way. What's it gonna look like?
Yeah, like a little.
Yeah, that would probably be pretty good close. Yep. So now your axis of rotation is right here. So your radius is right here. All right. So are we in terms of x or y? Y, because we are going to touch that y-axis. We don't have to necessarily touch it. We will today, but if we continue, we will touch it. So we are in terms of y. Okay. So we're going to have to switch it because this is in terms of x. So what are we going to do to switch y equals 1 minus x squared to terms of y? Solve for y, solve for x, y minus 1 equals negative x squared. Positive x squared equals negative. Okay, and then x equals, good. Okay, and this is the plus side, this is the negative side, so we're really only taking the plus side. Okay, this would be the negative. Okay, we want the plus side. All right, so what's my radius? Right minus left. Negative square root of negative y plus 1? No, plus, sorry. Minus 0, right? Just to be clear, this is 0 for your y. Okay? All right, so we're going to start with the area of a circle, pi r squared, then we're going to go to a volume of a disk. All right, pi r squared, h, where h is change in y. Okay, I'm ready for my radical, for my integral rather. Okay, pi r, we already did r. Negative y plus 1 squared dy. No, they're not. All right, now we need to find the limits. Remember, the limits have to involve y. So the bottom, of course, is 0. The top is 1 because that's the top. Sometimes it's a little bit more complex. All right. Before you plug into your calculator, let's clean it up because it's a lot easier to put in what? Negative y plus 1. All right, go ahead and throw it in your calculator. Find the rest here.
It's like turn into dy.
Or dx. And don't even put your pi in there till you're done, because this might be a nice number, and then you can just add the pi. But if you find yourself forgetting about the pi, then throw your pi in there, because you can't forget about it. And remember, you have to use that.
Yeah, no, that's not.
Okay, so what'd you get? So you get 5 or 2, because this piece is 1/2. Everybody good? All right. Okay, so you find the area find the radius part of that. All right. Okay, we got a graph here. Sometimes you have a graph, and sometimes you have to figure out, oh, which one's which. It's not usually that difficult. Okay, f of x equals 2 minus x squared. That's the blue one. Okay. G of x equals 1. Where's that? That is, and we're rotating it about the line, so it's, yes, it's going to look like this. It's going to look kind of like that first one we did. Right. Mary, did I miss it?
Yes.
That one, yeah. That's very similar. Okay. All right. Oops, what am I doing? Okay. So this is our rotation right here. Okay, so my radius, everybody draw your radius in. The radius should start middle, which is the axis of rotation, and should go up, down, sideways, what? Up. All right, so this is your radius right here. That's my radius. It starts at the axis of rotation, has to be perpendicular to that, and then it goes to the outside. This is the piece that we created, the solid, but the radius still starts in the middle and goes out. Good. I just didn't want it to get lost in the axis. But yes, you totally could. I'm just putting it somewhere. Okay, somebody tell me what my radius is. Okay, are we in terms of x or y? We're in terms of x, because if we get going, we hit the x. We're in terms of x, so what is it, Emma?
I got 1 minus x squared. I did 2 minus x squared minus 1.
2, very good. 2 minus x squared is the top, minus the bottom is 1. Regardless of where you draw that radius, 2 minus x squared is the top, 1 is the bottom. 2 minus x squared, remember the x is changing, but the boundary is still 2 minus x squared. Does that make sense? Okay, so area, pi r squared, volume, pi r squared h turns into change in x. All right, pi and ready for an interval. Because we're slamming all those discs in there, we're slicing it up. All right, r is 1 minus x squared simplified. I'm going to make a mistake here, a common mistake. df.
Square it.
Yeah.
Oh, thank you, Molly, you're the best. Okay, that is a common mistake because you got all these squares going, you forget to square the r. The r is very clear. Have that written, make sure you're squaring the r. Okay, so I'm looking for x's. I'm going this way. This seems like it's my smallest x. What are those things there? Intersection. That's where 1 equals 2 minus x squared, right? So negative 1 equals negative x squared equals 1, x equals plus and minus 1. Negative 1 and 1. Okay? Go ahead and throw that in your calculator. Because if you're going to square that out, remember you're going to square that as a binomial. Do what? I know it. They'll tell you a lot to just kind of pick some by hand, but this one gets kind of nutty. This one's got so much going on here in X50.
Wait, can you do that? Even?
It is even, yeah. Let me do the even. Good job, Ellie. It'll be easier if I do it by hand. Let's see, 15. 10.
Zero. The even rule. Oh.
There's your answer.
Which simplifies?
Simplifies to what?
Oh, never mind.
I messed up.
No.
I messed up.
Okay. So if you're doing this by hand, the even thing was nice that Allie mentioned, because we have two of the same thing from 0 to 1, then I don't have to do the 0 piece. Otherwise, I have to do the -1 there. Okay. If you're doing them, if it's on a multiple choice test, that's what your answer is going to look like. If it's on a free response, you can throw the pi in from the beginning. Give me one big decimal. If you're going to round the decimal, you might as well put the pi in and round it all together. Don't put like 6.428 pi. If you're already rounding, then round the pi with it. Multiply it out and then round it again. Okay? Just be careful about rounding too soon, but don't do that too much. Any questions about that one? Okay, I'm glad that you all are thinking about the solid, because sometimes you can just be like, yeah, it doesn't really matter, I got it. But it's good to kind of visualize the, I don't know why I said that so long, but anyway, visualize. Visualize. It is nice to visualize the solid there. All right. Okay, so this is the general rules here. If we're going from A to B, R of X is your radius. Okay, you can, that looks the same to me. Oh, okay. Thank you. And then we have, in terms of Y, your C to D is only because C is over here, A and B was usually here. Same idea, we pull the pi out. And now it's gross. All right. Be careful, radii in the disk method have to be perpendicular to the axis of rotation. You are not even going to probably think about this today, but please do, because it'll make the next 2 days a lot easier if you can recall that. Okay? Vertical radii need X's, horizontal radii use Y's. Okay. All right. You want to try this one by yourself? No.
Simple.
Yeah. Yes. We're going to go in terms of Y, right? So your radius is Y to the 3/2 minus 0. So change in Y. And then our bottom Y is 0, and our top is 2. That's Y to the 3rd, right? Mm-hmm. Very good. Okay. So it's not. That's it, right?
Ooh,
Come on.